Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Trust-Based Cluster Head Selection using a K-means algorithm for wireless sensor networks. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the application area and the research domain in the wireless sensor networks, where we have designed one of the clustering protocol to improve the energy in the system. So before moving to the video, let's talk about that what we will cover into this video. In this video, we will initially talk about that in which application areas the design system can be implemented in the real world. Then we will discuss that whatever the code we have designed, how to execute it, what are the software and the library requirements to execute it. Then what are the current systems, what kind of research has been done by the researchers recently, and what are the problems identified in them, and how the proposed method is handling those problems will be given into this video. Finally, the overall results and the comparison has been shown in order to demonstrate that our proposed approach is better in terms of certain parameters and the factors. So let's talk about the application areas. The wireless sensor networks or IoT networks are implemented and can be realistically used in many of the areas. That includes smart agriculture, where the remote location based surveillance can be done by using the sensors. Then automotives, where the parameters like accident detection or brake detection or any of the mishappening in the locations, many of the things can be tracked by using the sensors from the remote location. For the biomedical domain, like where patients can be remotely assessed by the doctors by checking their different medical factors. Then for the industrial, motorsports, and many other, even specifically for the areas like food monitoring, medical and diagnostic, defense and military based operations. So it is implemented in almost every of the area where we can remotely see the visuals and can do the appropriate steps to monitor those, right? But the major problem with these sensor network area is like the sensors are restricted with the energy. They have a small battery source, so in order to improve that, their lifetime must be longer. Let's take an example that the wearable devices that you are using these days, they are having the batteries in them. So if they are staying longer, then obviously it is a reliable device, else it will keep charging and all, right? So in the certain scenarios, it is very hard to replace the batteries. So this is one of the domain area in which the people and researchers are working. Inspired from this, we have developed this application for the IoT based wireless sensor networks. So let's see that what exactly the code and how to execute it. The folder we will provide you to run the code will be like this. So it will have the number of files with them. The whole code is implemented in the MATLAB, so you must have the MATLAB software with you. It should be a full version, so you can use 2015 or above, but make sure it is not a trial one, because certain libraries are not available in that. So in order to run this code, you just need to go to the folder and you just need to copy this path and then go to the MATLAB folder and paste it here. Control V and press enter. When you will press enter, all the files will be shown here. Here we have implemented the method with the basic code of the LEACH, which is a clustering protocol, and the proposed methodology. In order to run the code, you just need to select the file whatever you want to run, and here in the editor section there's a run command. So when you will click on the run command, it will execute the code. Here you can see the nodes have been deployed, the rounds has been running, and everything is happening for the same scenario which we are using in the proposed one. And finally the parameters have been shown in the graphical form. Here you can see, I will discuss about these later on. So here the results has been extracted and are being saved in the mat file. Same for the proposed one, you just need to run it, so it will execute their scenario and then compare it with the leach in order to show their effectiveness. Now let's talk about that, what we have done and what is the issues with the current system. Most of the people or the researchers, those are working in this domain, are they are having the areas where they can improve is like forming the clusters, cluster head selection, the communication among the nodes. So these are the areas where improvements are possible. So the traditional methods were basically the selection of the cluster head were restricted to the parameters like distance or energy only. Those are the physical parameters. Along with that, the clustering is being done, a cluster head selection, some of the models are doing on the probability based methods. Then the communication is basically on a normal scenario. So it is very important to select the cluster head in an effective way so that certain parameters can be covered. So inspired from that, in the proposed methodology, what we have done, we have proposed one of the strategy in which the cluster formation and the cluster head selection is improved, where we are introducing one more parameter other than the physical parameters, like that is the trust factor. It means the data droppage rate or the data transmission rate will be higher, droppage will be lesser. So it means the node that is selecting as a cluster head or the node which is getting the data will be selected on the basis of their previous behavior. So that is also known as trust of that node, along with the parameter including the distance with the sink, distance with the nodes, and the energy remaining with them for the communication. Here we have implemented the scenario by calculating the different parameters. Firstly, we have calculated the trust factor of the individual node. After calculating the trust factor, we have calculated the another factors including the, you can see here, we have calculated the energy required for the communication, the distance that it need to cover with the nodes, and the trust factor. So on the weightage based, we have selected these parameters and selecting the next hope as a cluster head. So for doing that, what we are doing, we have given a strategy that in the uh, initial stage, initially the distance has been calculated, and then that distance mat is calculated with respect to the sink. The nodes those are closer to the specific points given by the k mean will be, if they those if the nodes are under the range of 10 meters to the point that is given by the k mean scenario, then those node will be the recommended node. Then we will take the parameters like distance to the sink, total energy required, trust factor of the those particular nodes, those are under the range of 10 meters. These factors has been taken, and on basis of the selection criteria has been taken. So the if this selection factor will be maximum, then it is recommended that that node can be the cluster head. Why it should be maximum? Because it is directly proportional to the energy, inversely proportional to the distance, and directly proportional to the trust factor. So obviously if energy is higher and trust will be higher, those will be more recommendation. So high is there, distance 1 by distance, so it means distance is reducing, it means the selection criteria should be higher. So maximum the factor, maximum the chances of getting be the cluster head. So once the cluster head been selected, we have further did the communication among the nodes from cluster head to sink and node to cluster head by using the energy model equations of distance less than or greater than d node, which is calculated by under the root of EFS upon EMP. And then finally the parameters have been evaluated in terms of delay, dead nodes, alive nodes, packets sent to the base station and all. So when I'm running this code, in order to run this, let's see that what results we got. So when I'm running this code, you can see it is running for a number of rounds, and even it is calculating the time, because time complexity is very important in order to take the decision that to which node the data is to be transferred. So these are the parameters that we have calculated here. This is a proposed dead nodes with respect to rounds. These are the curve of the alive node. This is the packet sent to the base station. This is the energy consumption of the network with respect to round, and then we have calculated for how much delay is there for communication among them. So this is what that when the first node is dead, when the half node is dead, when the last node is dead in the network. Then we did the comparison it with the LEACH protocol, which I already shown. That you can see with the LEACH protocol, our proposed method is for the first node that it is almost 200 rounds more than the first dead node. But might be you are thinking that we are comparing it with the LEACH, but you can see many other state of art methods are not achieving this much good results. So you can follow certain other protocols to which you can compare the results. So in the lifetime also, you can see dead nodes and the live node curve is far away from the LEACH, which means it is more stable and more reliable. The packet transmission is higher, the packet delivery ratio is higher, energy consumption is lower. Here you can see this is the packet delivery ratio. Here the packet drop rate is lesser, throughput is higher, and finally the energy consumption is staying for longer period. So this proves the effectiveness of the proposed method in comparison to the existing LEACH, or even you can use any other state of art methods. Still further modifications are possible into it, because here we generally focused on selecting the cluster head and forming the clusters by the proposed methodology, and including the factor named trust, which actually provide us the higher delivery rate of the data instead of being only focusing on the physical parameter. So for more details you can contact us directly, and thanks for
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.